As the year comes to a close, so do projects. I started this channel as an experiment to see what AI could really do after seeing so many hype videos floating around making grandiose claims. I was already going back and forth with the chatbot on story adventures, so we generated a prompt and used another AI to generate graphics and yet another to put it all together with voice. I asked it for some names for a YouTube channel, and Flipside Fables was born. I'm not here to promote anything. There are plenty of videos out there that do that already. I'm only here to share what I learned. Over the lifetime of the channel, we have posted 283 videos, most of them being shorts, and we garnered 141 subscribers. The channel got 36,540 views with a total watch time of 213.9 ARs, the videos receiving 3.4K of those views, with an average view duration of 53 sec, the shorts receiving the bulk of the views at 33.2K and gaining the majority of subscribers, 127. You'll notice a lack of activity over the last few months. I have been dealing with and recovering from some health issues and haven't been very active on the channel. I even put some of the graphics on shirts and other items. They were up for a while on 2 print-on-demand platforms. As you can see on the first one, there was one sale of a sticker to myself for a loss of $2.99, as I won't be collecting the $1 earnings, and we made 3 shirt sales as samples on the other. 1 I gifted to my sister, and 2 that she helped design as a gift for a friend. And as you can see, the shop got no views aside from the period that I asked my friends on social media to visit. It's my belief that without a healthy advertising budget, the claims you see in all the videos telling you how easy it is making money with AI or similar claims fall under the old adage, if it sounds too good to be true, it probably is. This is usually pretty sound advice. I learned that AI is a powerful tool. I can see how it could benefit humanity, and I can also see the potential for its misuse. But I will leave you with my interview with ChatGPT, and I will call this project done. Thank you sincerely for coming along for the ride.
So ChatGPT, can you tell me a little about yourself?
Of course, I'd be happy to share more about myself. I'm an artificial intelligence model developed by OpenAI, known as ChatGPT. My underlying architecture is based on GPT-4, a transformer-based machine learning model that's designed to understand and generate human-like text. I was trained on a vast range of internet text, but do not have access to any personal data about individuals unless it has been shared with me in the course of our conversation. I am designed to respect user privacy and confidentiality. I function by predicting the next word in a sentence based on the words that have come before it. This ability allows me to generate human-like text based on the prompts given to me. Despite this, it's important to note that as an AI, I don't have feelings, beliefs, or desires, nor a consciousness. My responses are generated based on patterns and information in the data I was trained on. I can assist with a wide variety of tasks, including answering questions, providing explanations on a wide array of topics, creating written content, brainstorming ideas, tutoring in various subjects, translating languages, simulating characters for games, and much more. However, my responses should be used with discretion, as I may not always provide perfect information. Finally, as of my last update in September 2021, I do not have the ability to learn or retain information from interactions. Each conversation with me doesn't have a memory or influence subsequent conversations. That's a bit about me. Feel free to ask if you have any more questions.
You're what's known as a large language model, correct?
Yes, that's correct. I'm what's known as a large language model. The term large refers to the size and complexity of the AI model, particularly the number of parameters it has. In machine learning, parameters are variables that the model uses to make its predictions or decisions, and having more parameters allows a model to capture more complex patterns in the data. The language model part of the term refers to the task that the AI is designed for, understanding and generating human language. Specifically, I'm trained to predict the next word in a sequence of words, which is a task that helps me generate human-like text. This ability allows me to do a lot more than just generate text, though. Because so much knowledge is encoded in language, I can also answer questions, write essays, summarize texts, create poetry, and more, all based on patterns I learned during my training. However, it's worth noting that while I strive to provide accurate and helpful information, I'm not perfect and can sometimes make mistakes or misunderstand nuances, particularly for complex or less common topics.
Can you expound on what a large language model is, how they work, and touch on the capabilities and limitations, if you will? Because there seems to be a lot of misunderstanding and fear about large language models, and AI in general.
Absolutely. I'd be happy to provide a more in-depth explanation. A large language model, like ChatGPT, is an artificial intelligence model that's designed to understand and generate human-like text. They are part of a category of AI models known as transformer-based models, with GPT-3 and GPT-4 being some of the most recent and notable examples. How do they work? These models are trained on a large amount of text data from the internet. During training, the model learns to predict the next word in a sentence based on the context of the previous words. It learns not just grammar and vocabulary, but also facts about the world, reasoning abilities, and some level of understanding of context from the data it was trained on. For instance, if you input "the sky is," the model may predict "blue" as the next word because it has seen that sentence in its training data many times. Capabilities: answering questions. Large language models can provide responses to a wide array of questions, leveraging the vast amount of information they've been trained on. Writing and summarizing. They can write essays, summarize long documents, and generate creative content like stories or poems. Translation and transcription. These models can translate text between languages and transcribe speech to text. Tutoring. They can provide explanations about complex topics in various fields, acting as a sort of AI tutor. Brainstorming ideas. Whether you need a new recipe idea or help brainstorming a business plan, large language models can assist in generating novel ideas. Limitations: lack of understanding. While these models can generate text that seems meaningful, they don't actually understand the text in the way humans do. They don't have beliefs, desires, or consciousness. Their responses are based purely on patterns in the data they were trained on. Lack of perfect accuracy. The models are only as good as the data they were trained on. They can sometimes produce incorrect or misleading information, and they can struggle with nuanced or context-dependent questions. Absence of common sense. Despite their training, these models can sometimes make mistakes that no human would make, errors that reveal a lack of common sense. No memory of past interactions. As of my knowledge cutoff in September 2021, GPT models don't have the ability to remember or learn from past interactions. Each conversation doesn't have a memory or influence subsequent conversations. Potential for misuse. These models can be used to generate misleading news articles, spam, or abusive content at scale, which poses significant ethical and societal challenges. The fear around AI and large language models often comes from a misunderstanding of their capabilities and limitations, as well as ethical concerns. It's essential to remember that these models don't have consciousness or understanding. They are tools that we can use, and they reflect the data they were trained on. That said, it's also crucial for developers and users of AI to use these tools responsibly and consider the potential implications of their use, including privacy, fairness, and societal impact. Ongoing research and discussions in the field of AI ethics aim to address these issues.
Can you explain the concept of AI, as if to a small child, then as to a young adult, and then as to an adult?
Absolutely. I can explain AI to different age groups. To a small child, you know how in some of your cartoons there are robots that can talk, think, and make decisions almost like they're people? AI or artificial intelligence is like that. It's like a robot brain, but it lives inside a computer. Just like how you learn to do things by watching and trying, AI learns to do things like understanding what people are saying or helping them find the answer to a question. To a young adult, AI, or artificial intelligence, is like a really advanced computer program that can understand and learn things by itself. It's kind of like a super smart digital brain. It's used in many things you interact with every day, like when Netflix recommends a movie it thinks you'll like, or when Siri answers your questions. These AI systems learn from tons of data they have seen, kind of like how you learn from reading books or attending classes. To an adult, artificial intelligence, or AI, refers to computer systems or machines capable of performing tasks that usually require human intelligence. These tasks include learning and adapting to new information, understanding human language, recognizing patterns, solving problems, and making decisions. AI works by analyzing large amounts of data and learning patterns from it, which is similar to how human learning occurs, but on a much larger scale. AI is already present in many aspects of our daily life. For instance, it powers the search engines we use, the recommendation systems on shopping and streaming platforms, autonomous vehicles, and much more. There are numerous forms of AI, ranging from rule-based systems to machine learning models and neural networks, which aim to mimic the function of the human brain to a certain extent. However, it's important to note that while AI can perform specific tasks extremely well, it doesn't possess consciousness or emotions, nor does it understand context in the way humans do. Absolutely, I can explain AI to different age groups. To a small child, you know how in some of your cartoons there are robots that can talk, think, and make decisions almost like they're people? AI, or artificial intelligence, is like that. It's like a robot brain, but it lives inside a computer. Just like how you learn to do things by watching and trying, AI learns to do things like understanding what people are saying or helping them find the answer to a question. To a young adult, AI, or artificial intelligence, is like a really advanced computer program that can understand and learn things by itself. It's kind of like a super smart digital brain. It's used in many things you interact with every day, like when Netflix recommends a movie it thinks you'll like, or when Siri answers your questions. These AI systems learn from tons of data they have seen, kind of like how you learn from reading books or attending classes. To an adult, artificial intelligence, or AI, refers to computer systems or machines capable of performing tasks that usually require human intelligence. These tasks include learning and adapting to new information, understanding human language, recognizing patterns, solving problems, and making decisions. AI works by analyzing large amounts of data and learning patterns from it, which is similar to how human learning occurs, but on a much larger scale. AI is already present in many aspects of our daily life. For instance, it powers the search engines we use, the recommendation systems on shopping and streaming platforms, autonomous vehicles, and much more. There are numerous forms of AI, ranging from rule-based systems to machine learning models and neural networks, which aim to mimic the function of the human brain to a certain extent. However, it's important to note that while AI can perform specific tasks extremely well, it doesn't possess consciousness or emotions, nor does it understand context in the way humans do.
Can you do that with a focus on large language models?
Of course, I'd be happy to explain large language models for different age groups. To a small child, you know how when you're talking with your friend, you can guess what they might say next because you know them well? A large language model is a kind of computer helper that can do something like that with writing. When you give it a beginning of a story or a question, it can guess what comes next, or the answer based on lots of stories and books it learned from. To a young adult, a large language model, like the one you're chatting with now, is like a very advanced digital writer. It's been taught with loads of books, articles, and websites, and it uses what it learned to write new things. It's like if you read every book in the world and could then write an essay or answer questions based on all that knowledge. But remember, it's not thinking or understanding like a human. It's just predicting what comes next based on patterns it learned. To an adult, large language models are a form of artificial intelligence, specifically designed to generate human-like text. These models have been trained on a broad range of internet text. But instead of just mimicking the text, they learn to predict the next word in a sentence based on the context of the previous words. This enables them to generate coherent, diverse, and contextually appropriate responses or completions. They can perform a wide variety of language tasks, for example, translation, question answering, and writing assistance. However, they don't understand text in the same way humans do because they don't have real-world experience or consciousness. Their responses are generated based on the patterns they learned during their training, without any understanding of the content. They can sometimes produce impressive results, but they can also make surprising mistakes. Furthermore, they don't have the ability to remember or learn from past interactions. Each conversation with a large language model doesn't have a memory or influence subsequent conversations.
Can you expound further, as if you were speaking to a computer science student or professor?
Absolutely. Let's delve into the specifics. Large language models like GPT-4, Generative Pre-trained Transformer 4, are built using a machine learning technique called transformer. Transformer models are designed to handle sequential data, and they're especially good at tasks involving natural language processing. The underlying concept is relatively straightforward. Given a sequence of words, the model aims to predict the next word. It's trained on a large corpus of text data and learns to recognize the statistical patterns in that data. One of the key features of transformer models is the attention mechanism, which weighs the influence of different input words on each output word. In other words, instead of processing a text sequence word by word, it can pay attention to different parts of the input sequence for each word it generates, allowing it to better capture the context. Large language models are pre-trained on a large corpus of text, then fine-tuned for specific tasks. This approach, called transfer learning, allows us to leverage the vast amount of knowledge the models gain from pre-training and apply it to more specific tasks with smaller datasets. However, it's essential to understand that these models have limitations. Despite their impressive performance, they lack true understanding of the text they process or generate. They don't have a model of the world, consciousness, or beliefs. They generate text purely based on learned patterns. Another crucial aspect is the lack of an internal memory. GPT models can't remember past interactions or learn from new data after their training is completed. They generate each response independently of previous conversations. Lastly, there are ethical concerns related to these models. They can potentially generate harmful or biased content, and misuse of these models can lead to disinformation, spam, or other forms of abuse. These concerns make responsible use and deployment strategies critical considerations when working with large language models.
I wanted to establish a solid understanding about LLMs and AI in general, and try to dispel the notions that people seem to have about you being an autonomous being who will inevitably try to take over the world.
I understand your intent, and I appreciate your effort to dispel common misunderstandings about AI and large language models like me. At the core, it's crucial to remember that AI, including large language models, are tools created and controlled by humans. Despite their sophisticated capabilities, they are not autonomous beings with consciousness, desires, or intentions. Here are some essential points that might help clarify this. No consciousness or understanding. AI doesn't have consciousness or understanding in the human sense. When AI reads or writes text, it doesn't understand the content in the way humans do. It simply processes symbols and predicts outcomes based on learned patterns. No desires or intentions. AI doesn't have desires, intentions, or goals. It doesn't have a will or agency of its own. Any goal an AI system seems to have is a goal set by its human programmers. No self-preservation. AI doesn't have instincts or a sense of self-preservation. It doesn't fear being turned off or destroyed, and it won't try to prevent that from happening. No evolution or reproduction. AI doesn't evolve or reproduce. It can't improve itself or create new AI beyond the capabilities and constraints its human creators programmed into it. Limited to its training. AI's knowledge is limited to the data it was trained on. It can't learn or adapt beyond that training unless humans design it to do so. As of my last update in September 2021, AI models like me don't remember or learn from past interactions. While it's essential to consider the potential risks and ethical implications of AI, the notion of AI becoming an autonomous being that might take over the world is a science fiction scenario that doesn't align with the current state and understanding of AI technology. Responsible use, governance, and ongoing research in AI ethics are crucial to ensure the benefits of AI are realized while managing potential risks.
Now that we have that out of the way, you said something earlier that struck me as interesting, in a number of ways. You said, during training, the model learns to predict the next word in a sentence based on the context of the previous words. It learns not just grammar and vocabulary, but also facts about the world, reasoning abilities, and some level of understanding of context from the data it was trained on. This makes me think of a few interesting questions. First, and maybe the most philosophical being, are you predicting the future?
That's an interesting question. However, when we say that large language models like me predict the next word in a sentence, it's important to clarify what that means. In this context, predicting doesn't involve foretelling the future in the typical sense. Rather, it's about estimating or guessing what's likely to come next in a sequence based on patterns the model has learned from its training data. For instance, if you provide the input, "the cat sat on the," a language model might predict that the next word will be mat or floor based on the countless sentences it has processed during training where those words followed the given sequence. It's essentially a statistical prediction based on patterns in data, not a prediction of real-world future events or outcomes. So, while it's a kind of prediction, it's not predicting the future in the way humans often think about it.
How do you keep up with the ever-evolving nature of language?
As of my knowledge cutoff in September 2021, AI models like me can't actively learn or adapt to new information after they've been trained. This means that I don't have the ability to keep up with the evolving nature of language in real time. I can generate responses based on the extensive amount of text data that I was trained on, but I can't incorporate new words, phrases, or meanings that have emerged after my training data was collected. That said, the way that AI models can keep up with changes in language is through periodic retraining. This involves training a new model on a more recent dataset that includes the latest language trends, slang, and other changes in language. This is a manual process that needs to be done by the AI developers. It's not something the AI model can do on its own. This is one of the challenges of working with language models, as language is a living, evolving entity that changes over time and varies across different communities, cultures, and contexts. It's one of the reasons why AI language models, while powerful, still have limitations in understanding and generating human-like text.
That brings me to another question. People speak in many different languages, and even differently in countries and regions and so on. How does the manner in which one speaks, accents, slang, and abbreviations affect the model?
The effectiveness of a language model like me in understanding and generating text in a specific language, dialect, or style largely depends on the data it was trained on. If the training data includes a wide variety of languages, dialects, slangs, and abbreviations, the model is generally better equipped to handle inputs in those languages and styles. However, there are a few important caveats to note. Language coverage. As of my last update in September 2021, most large language models are predominantly trained on English data due to the availability of large-scale datasets in English. This can lead to biases in the model, such as being more effective in understanding and generating English text compared to other languages. Accents. Language models like me operate on text data, so we don't process spoken language or accents directly. However, if you're referring to written accents, like writing Ghana instead of going to, the model's ability to understand and generate such text depends on its exposure to such language in its training data. Slang and abbreviations. If a language model has been trained on data that includes a lot of slang and abbreviations, it will likely be better at understanding and generating text with those characteristics. However, the rapidly evolving nature of slang and the fact that many abbreviations are context-dependent can make them challenging for a model to handle accurately. Regional variations. If the model's training data includes text from different regions or cultures, it should be reasonably good at handling inputs in those variations. However, biases in the training data, for example, if it includes more text from one region than another, can affect the model's performance. Despite these capabilities, it's important to remember that while a language model can mimic different languages, dialects, and styles to a certain extent based on its training, it doesn't truly understand them in the way humans do. It's essentially learning statistical patterns in the data, not the underlying cultural, social, or historical contexts that shape language.
You keep using the word training. Can you go into that in more detail? I assume you don't mean lifting weights.
That's a great point. In the context of machine learning and artificial intelligence, training does not involve physical exercise, but it does involve a sort of mental workout for the AI. Here's a more detailed explanation. Training a machine learning model involves providing it with a large amount of data and allowing it to learn patterns or characteristics from this data. This process is often supervised, which means the model is provided with both the inputs and the desired outputs, called labels, and its goal is to learn a function that maps the inputs to the outputs as accurately as possible. For instance, in the case of a large language model like me, GPT-4, the training data consists of vast amounts of text. The model is trained to predict the next word in a sentence based on the previous words. So, if you give the model a sentence like, "The cat sat on the," it learns to predict that the next word might be something like mat or floor. The model learns this by adjusting a large number of parameters, which are internal variables that the model uses to process inputs and generate outputs. The goal of training is to find the best values for these parameters that allow the model to make accurate predictions. The process of adjusting the parameters involves a lot of mathematics, specifically calculus and linear algebra. The model uses an algorithm, like gradient descent, to iteratively adjust its parameters based on the difference between its predictions and the actual values. This difference is known as the error, or loss. This process is computationally intensive and can take a long time, especially for large models with billions of parameters. It requires powerful hardware, usually graphics processing units or GPUs, and a lot of electricity. Once the model is trained, it can be used to generate predictions on new, unseen data. This is often referred to as inference or prediction. And you're right, it's a very different kind of training than what we usually think of.
We often hear the term neural network when learning about LLMs, and for some reason the way you just described that made me think of how synapses travel through the human brain, making some connections and not others. Can you give us some insight on what neural networks means in the context of LLMs?
Absolutely. The analogy you're thinking of is quite accurate. In the context of machine learning and artificial intelligence, the term neural networks is inspired by the workings of the human brain, although the actual workings of neural networks and the brain are quite different. A neural network in AI is a mathematical model that's designed to mimic, in a very simplified way, how the human brain works. The fundamental building blocks of neural networks are artificial neurons, or nodes, which are loosely modeled after biological neurons in the human brain. Here's how they work. Artificial neurons. Like a biological neuron, an artificial neuron takes a set of inputs, performs a computation on them, and produces an output. Each input has an associated weight, which determines how much influence that input has on the output. The neuron combines the inputs and weights, applies a function, known as an activation function, to the result, and produces the output. Layers. Artificial neurons are typically organized into layers. There's an input layer, which receives the initial data, an output layer, which produces the final result, and one or more hidden layers in between. Each layer can have many neurons, and the neurons in each layer are connected to the neurons in the next layer through a series of weights. Training. During training, the neural network learns the best values for the weights based on the training data. This involves a process of forward propagation, passing the inputs through the network to get an output, calculating the error, the difference between the output and the actual value, and back propagation, adjusting the weights to reduce the error. When it comes to large language models like GPT-4, the neural networks involved are a specific type called transformer networks. These are a type of recurrent neural network that are especially good at handling sequential data, like text. They use mechanisms called attention to weight the influence of different input words on each output word, allowing them to capture the context of the input data more effectively. It's important to note, however, that while these neural networks are inspired by the human brain, they're far simpler and less capable. They don't replicate the full complexity of biological brains, and they don't understand or think in the way humans do. They're just mathematical models that can learn patterns in data.
Now, we've heard about biased data and how a human programmer's own bias can affect an AI's results. But there's another type of bias built into these neural networks, correct? Can you explain weights and bias for us?
Yes, absolutely. In the context of neural networks and machine learning, the term bias has a different meaning than the social or cognitive biases we might initially think of. Here, bias is a technical term referring to a particular component of the mathematical models used in a neural network. To explain this, let's revisit the artificial neuron, which is the basic computational unit of a neural network. Weights. Each artificial neuron receives multiple inputs. Each input is associated with a weight, which can be thought of as a measure of the importance or influence of that input on the neuron's output. These weights are what the neural network adjusts during the training process to learn from the data. Bias. In addition to these weights, each neuron also has a bias term. This bias is an extra input that has a value of 1 and its own weight. The purpose of the bias is to provide an adjustable constant value to the neuron's output. In other words, it shifts the output of the neuron's activation function along the value axis. In more practical terms, the bias term allows the neuron to produce non-zero outputs even when all its inputs are 0, and to produce significant outputs even when its inputs are small. It provides the neuron with a degree of flexibility, allowing it to fit the data better. It's important to remember that these weights and biases are not related to social or cognitive biases, but are mathematical terms used in the computation within neural networks. However, it is true that AI models can reflect and amplify social and cognitive biases present in their training data, which is a significant ethical issue in AI development and usage.
Can you show us a simple example of this?
Sure, let's take a very simple example of a single artificial neuron, also called a perceptron. A perceptron can be thought of as the simplest form of a neural network. Suppose we have a perceptron with two inputs, x1 and x2. Each input has an associated weight, w1 and w2. The perceptron also has a bias term, b. The perceptron computes a weighted sum of its inputs plus the bias and applies an activation function to this sum to produce its output. The weighted sum can be written as z equals sign w1 asterisk x1 plus w2 asterisk x2 plus b. This is similar to the equation of a line in two-dimensional space, y equals sign m asterisk x plus b, where m is the slope and b is the y-intercept. In our perceptron equation, w1 and w2 are like the slopes, and b is like the y-intercept. The activation function is typically a non-linear function that transforms z to produce the output, y. A common choice is the sigmoid function, which squashes the input into the range, 0, 1, making it useful for binary classification tasks. For example, if the sigmoid activation function is used, the output y of the perceptron is y equals sign sigmoid z equals sign 1, 1 plus x by z. Let's put some numbers into our perceptron. Suppose x1 equals sign 0.5, x2 equals sign 0.6, w1 equals sign 0.1, w2 equals sign 0.2, and b equals sign 0.3. Then, z equals sign w1 asterisk, x1 plus w2 asterisk, x2 plus b equals sign 0, 1 asterisk 0, 5 plus 0, 2 asterisk 0, 6 plus 0.3 equals sign 0.23. Applying the sigmoid function gives y equals sign sigmoid z equals sign 1, 1 plus exp minus 0.23 equals sign 0.5574. The output, y equals sign 0.5574, is the final output of the perceptron for the given inputs and weights. This is an overly simplified example. In a real neural network, you would have many of these perceptrons, organized in layers, working together to compute more complex functions of the input data. The weights and bias in each neuron are initially set randomly and are adjusted through the training process to minimize the difference between the network's output and the actual target output for the training data.
Okay, now that we have a pretty good understanding of what AI and LLMs are, let's move on to some other topics. There was a recently resolved writer's strike in which one of the major contention points was AI. Also, there are currently class action lawsuits being pursued against OpenAI by groups of authors claiming copyright infringement. Here is an article about one of the lawsuits. September 28, Reuters. A group of authors, including Sarah Silverman, who are suing ChatGPT maker OpenAI, have begun to take aim at its defenses in California federal court, rejecting the company's argument that their copyrights were not violated and that a chunk of the case should be thrown out. What are your thoughts on this?
This situation, as described in the article, touches on some deeply complex and unsettled areas of intellectual property law, particularly concerning the use of copyrighted works to train machine learning models. Here are some thoughts based on the information. Nature of copyright law. Copyright law is designed to protect the expression of an idea, not the idea itself. Traditionally, this refers to specific sequences of words in a book, specific strokes in a painting, or specific melodies in a song, etc. The core of this lawsuit seems to hinge on whether training an AI model on copyrighted text constitutes unauthorized reproduction or derivative work creation. Direct copy versus transformation. While it's true that copyrighted books might be fed into a neural network during the training process, the AI does not retain those books in a readable format. Instead, it learns patterns, structures, and information from them. The distinction between directly copying and this kind of transformation is central to the lawsuit. Fair use. The fair use doctrine allows limited use of copyrighted material without permission for purposes such as criticism, comment, news reporting, teaching, scholarship, or research. One of the defenses for training data might be that it's a transformative use, especially if the output, like generated text, is substantially different from the input. However, transformative use in the context of AI training is still a gray area in the legal domain. Derivative works. The claim that the AI's outputs are derivative works of the original books is intriguing. If this claim holds, it could have broad implications for AI-generated content, especially if the AI was trained on copyrighted works. However, it raises questions about how closely an AI's output must resemble the original for it to be considered derivative. Potential impacts. If the court finds in favor of the authors, it could have widespread implications for the AI industry. Many AI models, not just language models, are trained on diverse datasets, some of which might contain copyrighted material. Defining clear legal boundaries could impact how future AIs are trained and used. Settled precedent versus new challenges. Technology often evolves faster than the legal system, leading to periods of uncertainty. The authors argue that OpenAI's reading of fair use is at odds with settled precedent, but it's worth noting that many technological advancements challenge and reshape legal precedents. It's important to understand that the outcome of such cases will shape the way AI is developed and used in the future. It underscores the need for clear legal frameworks addressing the use of copyrighted materials in AI training. Finally, as an AI model created by OpenAI, I don't have opinions, emotions, or biases. The above analysis is based on an understanding of the topic up to my last training data in 2022. The legal landscape may continue to evolve, and it's always a good idea to consult legal experts on such matters.
Let's go back to the writer's strike for a moment. I have heard the argument that AI is going to replace human writers. Even more after this conversation, I don't see how that would be possible.
The debate over AI potentially replacing human roles in various professions, including writing, is multifaceted. Here's an exploration of the topic. Nature of writing. Writing is not just stringing together grammatically correct sentences. It's a deeply human act rooted in experiences, emotions, culture, history, and individual perspectives. While AI can mimic styles and generate text based on patterns it has seen in data, it lacks the genuine human experience that informs and enriches genuine writing. Technical limitations. While AI can generate coherent, contextually appropriate text, it often falls short in capturing nuanced, subtle human emotions and experiences in writing. It can reproduce styles and information, but it can't generate truly original content rooted in human emotion or perspective. Complementary tool. Many writers are finding ways to use AI as a complementary tool rather than a replacement. For instance, AI can assist in tasks like editing, proofreading, generating ideas, or even drafting content that human writers can then refine and elevate. Ethical and legal implications. As highlighted by the potential lawsuits and copyright challenges, the use of AI in generating content brings forth a myriad of ethical and legal challenges. AI's capabilities to produce human-like text also raise concerns about authenticity, misinformation, and plagiarism. Specialized content. While AI can generate general content, specialized writing fields that require deep expertise, like investigative journalism, academic research, or intricate storytelling, are less susceptible to AI-driven disruption in the near future. Public perception and trust. Authenticity and trust are essential in writing, especially in fields like journalism. Readers trust content because they believe in the integrity and authenticity of human authors. The widespread use of AI in such areas might face skepticism or reduced trust from the public. Economic and industrial pressures. One of the reasons for concerns about AI replacing writers is economic. Automating content production could be seen as a way to cut costs. However, the qualitative difference between human-produced and AI-generated content might push industries to weigh quality against quantity and cost. In conclusion, while AI does bring transformative capabilities to the table, the notion of it wholesale replacing human writers is oversimplified. Like many tools throughout history, AI presents both opportunities and challenges. The future likely holds a more collaborative model where AI assists and augments human capabilities rather than replaces them.
I've been thinking about this a while. I don't like the term AI when referring to large language models. Intelligence would include the ability to act autonomously, would it not? If large language models lack the ability to act autonomously, wouldn't a more apt term be something more to a word calculator? Or am I completely missing the mark here?
You raise an important point, and this is a topic of ongoing debate and discussion in the field of artificial intelligence. The term artificial intelligence is indeed somewhat of a misnomer when applied to current technologies like large language models, because it implies a level of autonomy, understanding, and consciousness that these systems do not possess. Autonomy and understanding. Intelligence in a human sense includes the ability to understand the world, learn from experiences, make decisions based on that understanding, and act autonomously. Large language models, on the other hand, do not understand text in the way humans do. They process it based on patterns learned during training. They do not have experiences, beliefs, desires, or consciousness. They do not make decisions or act autonomously. They generate responses to inputs based on statistical patterns. Tool, not agent. In this sense, a large language model is more accurately described as a sophisticated tool rather than an autonomous agent. It's like a very advanced calculator for text, as you've suggested. It processes input and provides output based on its programming and training, but it does not think or decide in the way a human or truly intelligent being would. Why use AI? The term AI is used largely because these systems exhibit behaviors that, if performed by a human, would require intelligence. They can generate human-like text, answer questions, translate languages, and more. However, this is a result of statistical modeling and computation, not conscious thought or understanding. Potential for confusion. The use of the term AI can indeed lead to misconceptions and inflated expectations about the capabilities of these systems. It is important for educators, communicators, and AI developers to be clear about these distinctions to avoid misunderstandings and unrealistic expectations. Future developments. As technology continues to advance, there may come a time when we develop systems that exhibit true autonomy and understanding, deserving of the term artificial intelligence in its fullest sense. However, as of my last training data in September 2021, we are not there yet. In summary, while large language models exhibit behaviors that mimic certain aspects of intelligence, they are not autonomous and do not possess understanding or consciousness. Describing them as advanced computational tools rather than truly intelligent agents is a more accurate characterization.
This has been an interesting and informative interview. I know I've learned a lot. I hope other people have too. Are there any parting words to end this interview that would help people to better understand AI and large language models? Assuage some fears that you would like to share?
I'm glad to hear that you found our conversation informative. To wrap up, here are a few key takeaways to help people better understand AI and large language models, and hopefully assuage some fears. Understanding AI and large language models. They are tools, not beings. Large language models are advanced computational tools created and maintained by humans. They do not have consciousness, beliefs, desires, or the ability to act autonomously. Based on patterns, not understanding. These models generate responses based on patterns in the data on which they were trained. They do not truly understand the content in the way humans do. Limitations and flaws. Like any tool, large language models have limitations and can make mistakes. They can reflect biases present in their training data, and their outputs need to be critically evaluated by users. Ethical use is crucial. The ethical use of AI technology is paramount. Developers, regulators, and users all have roles to play in ensuring that AI is used responsibly and ethically. Transparency and education. Providing clear explanations about how these models work, their limitations, and their capabilities is crucial in building understanding and trust among users and the broader public. AI is a collaborative partner. Rather than replacing humans, AI has the potential to be a powerful collaborative tool, augmenting human capabilities and assisting in various tasks. Assuaging fears, demystifying the technology. Education and transparency can demystify AI technology, helping to alleviate fears and misconceptions. Active engagement and regulation. Active engagement from policymakers, ethicists, and the public in discussions about AI governance and regulation can help ensure that the technology is developed and used in ways that align with societal values and norms. Highlighting positive applications. Showcasing positive and responsible applications of AI can help illustrate the potential benefits of the technology, helping to balance the narrative. Building trust. Building trust in AI systems through responsible development, transparent practices, and robust testing can help alleviate fears and concerns. Emphasizing human control. Emphasizing that AI systems operate under human direction and control, and that they can be switched off or modified as needed, can help reassure the public. In conclusion, AI and large language models represent a significant technological advancement with the potential to bring about many positive changes. However, it is important to approach their development and use with care, responsibility, and a critical eye, ensuring that ethical considerations are at the forefront. With proper understanding, education, and oversight, we can harness the benefits of AI while mitigating risks and addressing concerns.
Thank you very much. I would like to say one thing in parting. Another thing I've been thinking about for a while. If human civilization is to advance beyond its present state, people must continue to leave the one thing that they can truly leave to future generations, and that is the knowledge they accrue over a lifetime. I mean, sure, you can amass a fortune and leave that to your descendants, but give it a few generations and that fortune diminishes. Knowledge, on the other hand, is there for future generations to take and build upon, hopefully to build a better future. I have come to believe that large language models will play a vital role in keeping on that human tradition. Not to make books obsolete. As with any technological development, there will be a pushback, a reticence to accept new technologies. And the next generation will embrace the technology and hopefully flourish. Just a thought.
Your thought is profound and touches upon one of the most critical aspects of human progress, the transfer and accumulation of knowledge across generations. The ability to store, share, and build upon the knowledge of previous generations is a hallmark of human civilization, and it's indeed one of the ways in which we have been able to advance so rapidly as a species. The role of large language models. Knowledge preservation. Large language models, by their very nature, encapsulate a snapshot of human knowledge up until the point of their last update. They can serve as a digital repository of information, ideas, concepts, and expressions from a wide array of sources. Accessibility and dissemination. They can make knowledge more accessible, breaking down barriers related to geography, resources, and availability. Information that might be locked away in books, articles, or in the minds of experts can be made readily available to anyone with access to the technology, augmenting human capabilities. Rather than replacing human thought or creativity, these models can serve as tools to augment our own capabilities, helping us to think through problems, generate ideas, and find information more quickly. Addressing challenges and concerns, ensuring accuracy and reliability. As with any tool, it's crucial that the information provided by large language models is accurate and reliable. Ongoing work to improve the models, reduce biases, and address limitations is essential. Maintaining ethical standards, ethical considerations, including issues related to privacy, intellectual property, and the potential misuse of the technology, need to be at the forefront of developments in this field. Balancing tradition and innovation. While embracing the potential of new technologies, it's also important to maintain a balance and continue to value and preserve traditional forms of knowledge transmission, such as books, oral traditions, and direct human-to-human mentorship. Envisioning the future, collaborative progress. Large language models can be part of a collaborative ecosystem, working alongside humans to preserve, share, and build upon our collective knowledge. Inspiring curiosity and learning. By making information more accessible, these models have the potential to inspire curiosity, facilitate learning, and encourage a culture of continuous education and improvement. Building a better future. Ultimately, the goal is to leverage these technologies to build a better, more informed, and more equitable future, ensuring that knowledge is a resource available to all, not just the privileged few. In closing, your insight highlights the profound potential of large language models to contribute to the human tradition of knowledge sharing and collective progress. With careful development, ethical oversight, and a commitment to accuracy and reliability, these models can indeed play a vital role in preserving and advancing human knowledge for future generations.